Hello, dear friends, and welcome back to more Inventing the Modern World. In this part, we will explore the age of the engineer, individuals who spearheaded monumental shifts in the way in which we live in this modern world we exist in today. A quote here by E.M. Bataille, quoted in Samuel Smiles' Lives of Bolton and Watt of 1865, states that the part which James Watt, played in the mechanical application of the force of steam can only be compared to that of Newton in astronomy and of Shakespeare in poetry. Here we have a wonderful close-up of Robert Stephenson's rocket of 1829, an experimental engine that firmly established the viability of the locomotive. It brought together into one design three crucial innovations: the multi-tubular boiler, the blast pipe, and direct drive from piston to wheel. None of them were original to the rocket, but their use in combination was highly successful. So, if the impact of the Industrial Revolution was patchy, the far-reaching nature of changes in technology became increasingly clear to many in the mid-19th century, as new transport and communications networks extended across countries and continents. Now, such innovations were brought to popular attention through deliberate publicity campaigns, and the promotion of progress also became institutionalized through the holding of regular exhibitions, showcases for new products and inventions. One outcome of the popularization of the notion of progress was the increasing lionization of the engineer, personified as the creative force responsible for the transformation of the landscape and dramatic changes affecting so much of everyday life. The first to achieve such treatment was James Watt, eulogized as the modern Archimedes for single-handedly conceiving the steam engine, the mighty invention that formed the basis for Britain's greatness. So as early as 1824, a monument to Watt was commissioned for Westminster Abbey, and before long provincial towns were erecting statues and memorials to him as well. In 1853, the Royal Navy launched the 90-gun ship James Watt, thereby conferring an honour normally reserved for dead admirals, members of the royal family, and classical deities. So the stereotype of the lone genius, usually from a humble background, struggling with adversity to become a benefactor of mankind, was parodied by Dickens in the 1850s in Bleak House and Little Dorrit, and in the following decade, Samuel Smiles established a whole pantheon of heroes of the Industrial Revolution in his Lives of the Engineers and Industrial Biography. They depicted their subjects as paragons of self-help, combining mechanical genius with infinite patience and industriousness, and went a long way towards establishing an authorized version of engineering progress, leading to perceptions which have never quite been eradicated. Here's a very romantic painting up here showing the young Watt demonstrating his fascination with steam. And over here we have the mature Watt as the lone genius. Almost like a Roman emperor there. So the popular notion of single-minded great men often failed to do justice to their versatility. They were exclusively identified with specific inventions or undertakings. Their interests were invariably broader. Watt had been a surveyor, an instrument maker, before developing an interest in steam engines. Joseph Bramah, best known for the machine tools he invented and as an hydraulic engineer, also invented a water closet and an ever-pointed pencil. William Armstrong, another excellent hydraulic engineer and entrepreneur, also conducted experiments with electricity in his spare time. So many heroic figures were motivated by far less exalted ideals than the myth-makers chose to assign to them. Bolton and Watt's aggressive defence of their patent rights delayed further improvements to the steam engine in Britain by several years, and George Stephenson's quarrelsome nature ensured that his contribution to early railway his individual heroes were given or assumed the credit of actions of others. Thus, George Stevenson was happy to take and continues to receive credit for much of the work of his son Robert. Earlier, James Watt had taken great pains to discredit any other claims to innovations in steam engine technology. And again, we can see that in today's society, can't we? Certain highly wealthy men or individuals, or I say men, my mind just jumps to patriarchal things that have been introduced to me here, but people, human beings, who control the narrative, being able to suppress other progress in the pursuit of their own legacy and name. So even if inventors did make decisive contributions, they invariably borrowed freely from the work of predecessors or colleagues. So the extravagant praise heaped on board ignored the earlier Newcomen engine and the work of contemporaries such as Trevithick or Hornblower. James Naismith didn't single-handedly introduce the steam hammer. Alexander Graham Bell's contribution to the telephone extended little beyond the first imperfect prototype, and the persistent emphasis on a small number of well-known inventions plays down the achievements of a legion of unjustly forgotten technicians responsible for the continuous stream of steady improvements that ensured the technology never remained static. Here's an adapted atmospheric steam engine at Coalbrookdale, devised in 1712. These machines were used to pump water out of coal and tin mines. They were cheap and easy to maintain, and they remained in use long after the advent of efficient but expensive Watt engine. The machine in the picture, installed as late as 1790, had probably been built on the spot. The public could be extremely fickle. Some inventors skilled in the art of self-publicity could receive full recognition for their efforts, and others could be ignored or receive only belated acknowledgement. Samuel Morse eventually achieved legendary status in the United States. A statue to him was unveiled in New York's Central Park during his lifetime, but only after years of similar treatment in Europe, where he had long been showered with decorations and honorary titles. Richard Trevithick here is a sketch of a recoil engine, a type of reaction turbine. The arm on the right here was designed to rotate like a Catherine wheel, and a poster here for his portable engine. Here's London Railway of 1808, a brief form of public entertainment in the days before the full potential of this engine was understood. That's hilarious, isn't it? Just a little ring for a little train to go choo-choo. But you haven't actually got a full working railway system yet, and people didn't necessarily understand the impact of it. That is funny. This is Oliver Evans, the American inventor who constructed a high-pressure steam engine in 1804. And James Watt had dismissed the use of high pressure as dangerous and discouraged further research. But the work of Evans, Trevithick and others made it clear that the future of steam power lay in this direction. So it's interesting, isn't it, that the parents of these inventions often, if they got their own way, would have actually seen these inventions slowly disappear into the ether based on their potential stubbornness. Here we have the North Church Tunnel, one of 9 on the Stephenson's London and Birmingham Railway. It opened in 1838 and cost £53,000 a mile, and Euston, its London terminus, was the capital's first big station. That's hugely expensive, but you can see, look at that glorious structure there, the Britannia Bridge, taking the London to Holyhead Railway across the Menil Straits. And this is a cross-section of the Tubular Bridge. It is here. So here's Robert Stevenson. So even if Smiles and his contemporaries painted an idealised picture of certain engineers, the profession as a whole earned the accolades heaped upon it. The examples of Robert Stevenson and his embarked kingdom Brunel show what seemingly limited capacity for hard work allied with brilliance and versatility could achieve. Both died within weeks of each other in 1859, aged 56 and 53 respectively, outliving their famous fathers by only a decade. Both had been worn out prematurely by a succession of demanding projects, invariably at the cutting edge of current practice. Robert Robert Stephenson began an apprenticeship as a mining engineer, but his career was almost entirely devoted to the railways. So apart from designing the rocket that demonstrated once and for all the viability of the steam locomotive at the famous Rainhill trials in 1829, he worked on a number of major schemes, from the pioneering Stockton and Darlington and Liverpool and Manchester lines that launched the railway era, to grander projects linking London with Birmingham and the north, as well as many lines in Europe. Railway building involved much more than simply laying the track. A cutting excavated through rock at Olive Mount, part of the Liverpool and Manchester Railway, in which Robert Stephenson assisted his father George, can be seen here. A huge amount of terraforming. Wow, look at the painting here. Wonderful. Is that a Turner or something? Yes, Turner. Brunel here, and with his contemporary cigar here. Customary cigar, at the first abortive attempt to launch the Great Eastern in 1857, and work on the Albert Bridge at Saltash, which took the Great Western Railway across the Tamar Estuary into Cornwall, completed in 1859, months before Brunel's death. Rain, steam and speed, Great Western Railway. And here is a painting, Turner's evocative depiction of a locomotive in full steam. So Brunel was a general engineer par excellence, with spectacular contributions in several fields. He's remembered primarily for the Great Western Railway, always regarded as the greatest of the British lines, and for the glorious Clifton Suspension Bridge. He collaborated with his father on the Rotherhithe Tunnel and the world's first tunnel under a riverbed. Probably his greatest contribution to engineering was the construction of 3 mammoth steamships, the Great Western in 1837, Great Britain in 1845, and Great Eastern in 1859, that marked successive milestones in the use of steam over long distances. And of course, would have greatly contributed to British sea power, which drove the British Army across most of the planet. Here's a lovely looking glass goblet commemorating the opening of Robert Stephenson's Newcastle High Level Bridge in 1849, and the first German line. Celebrations accompanying the opening of the Nuremberg to Firth Railway in 1835 are depicted here. This is an invitation card to the official opening of the Forth Bridge in 1819. The Prince of Wales, later King Edward VII, performed the ceremony by symbolically closing the last rivet with a silver key. Church and state often came together to endorse progress. At the benediction of the Rouen and Le Havre Railway in 1847. So strange. And the enthusiastic reaction to the first exchange of telegraph messages between Washington and London in 1858. The revelers could not have foreseen that the cable would break within weeks. So textile machines, stationary steam engine, advances in metallurgy weren't necessarily visible to the average inhabitant outside the main industrial towns, but the coming of the railway, or the launching of a regular steamship line, galvanised public opinion. If a small minority bemoaned at the clearance of buildings or stretches of countryside in advance of a railway line, the majority was highly enthusiastic. Inclusion in a new transport route brought the promise of increased trade and prosperity. Access to a network seemed virtually synonymous with membership of the modern world, and each stage of the process served as an occasion for celebration. One small French town was said to have rung its church bells simply on hearing the news that a proposed railway line passing through it had been duly authorised. Carefully preserved wheelbarrows and spades used to dig the first sod testified to the symbolic significance attached to the inauguration of railway construction works. Even when crowds were absent, symbolism was maintained for the camera. A golden spike used to make the final connection of the first transcontinental rail link across the United States in 1869. And most opening ceremonies involved festivities on a lavish scale, with the attendance of the company directors, engineers and contractors, alongside representatives of the municipal authorities, local politics numbers of lines throughout Britain and northwestern Europe, forming the beginning of regular networks linked by telegraphs and run with the help of timetables, cost accounting and signalling system. It really must have been a new world. We take for granted how instant and accessible our travel can be these days, but could you imagine never having something like this to having something like this? Here's got an iconic image of an American locomotive crossing a wooden trestle bridge during the construction of the Transcontinental Railway. Here's a poster advertising trips to New York to see the Great Eastern Steamship. And here's the Transcontinental Link, the meeting of the Union Pacific and Central Pacific Railways at Brunel in Utah in 1869. Talking about industrial and transport, I do apologise if you can hear quite a number of vehicles moving in the background. It's rained very heavily here, and the space in which I record this content is unfortunately quite close to it. I live in a very small abode, so I do apologise if it's encroaching on your listening experience. By the year 1890, the United States had built a network larger than that of Western Europe, extending over 150,000 miles of line. By the end of the century, railways had been built through some of the most remote regions, opening up the rich untapped resources of the New World and areas of recent settlement in Australasia, South Africa and Latin America. In India, Central Asia and Africa, major lines were constructed to serve the interests of the great empires. Railways were to change everyday life in other ways, even for those who never travelled. The establishment of networks necessitated the standardisation of time, first within individual countries and later across the whole world. In Britain, the Greenwich Standard gained general acceptance in mid-century and was legally confirmed in 1880 GMT, and 4 years later it was set as the 0 point for international time. Here's a railway depot in the US at City Point, Virginia. The American Civil War was the first major conflict in which railways played a strategic role. And just as the railway had revolutionised land transport, the use of the steamship transformed maritime trade. Steady improvements to marine engines, mainly to reduce coal consumption, enabled steamships to extend their range and bring down costs. And although Brunel's great vessels had not been commercial successes, several regular transatlantic services were thriving in the 1860s. By the end of the century, sailing ships had been virtually banished from the main trading routes. Freight charges and passenger fares dropped considerably, and this provided a great stimulus to international trade. It enabled large numbers of people to cross the oceans in search of a better life. Between 1880 and World War I, over 30 million Europeans moved to other continents. With such journeys now cheaper, faster and safer than ever before, not all those who travelled intended to settle. A significant number of temporary migrants were returning to Europe with money earned overseas. And other great advances came from the use of electricity to transmit information. Several early proposals for an electromagnetic telegraph came to nothing until the collaboration between Cook and Wheatstone produced the first practical model in 1837. Telegraphs were developed in the United States by Samuel Morse and his partner Vail, who adopted the data and dots and dashes code widely used until recently, and national telegraph lines were laid alongside the railways. So here are the Thames Iron Works shipbuilding premises in 1867. And the Hamburg America line carried huge numbers of European immigrants to the United States. Calcutta's steamships here in the Hooghly River are being loaded or unloaded. The derricks swing the cargo into the holds or waiting lighters. Fantastic images in this book, aren't they? The Great Eastern here, look at the size of that. Whoa. It's taking on board the third transatlantic telegraph cable in 1866. The first to achieve a permanent link between Britain and North America, coiling the cable below deck. Cross sections of the cable are here. What it looked like. once moved. Astor pointed a succession of letters, so building up the message, Samuel Morse, the inventor of the Morse code that made this machine obsolete in 1854. Charles Dickens remarked that few things that I saw took my fancy so much as the electric telegraph piercing like a sunbeam right through the cruel old heart of the Colosseum at Rome. And Telegraph House at Trinity Bay in Newfoundland, where the transatlantic cable reached the North American continent. So communications technology was further transformed with the conversion of the human voice into transmittable form thanks to the development of the telephone in 1876. The first international line opened between Brussels and Paris in 1887, and by the end of the century nearly 2 million phones were in use. Many of the improvements to the telephone came from Thomas Edison, an excellent example of the engineer, scientist, inventor and entrepreneur combined, and the works of pioneers like him and Sebastian de Ferranti paved the way towards the wider use of electricity and the establishment of a power supply network that would eventually embrace every home business in the developed world. So with the growing complexity of the various technological systems and rapid expansion of the specific knowledge and experience required to remain at the cutting edge of developments, the all-round brilliance of a Brunel was no longer enough, and the profession branched out into several specialist areas. So it was soon possible to distinguish between civil, mechanical, electrical, sanitary and marine engineers, to name only the most important branches of the profession. And as industrialization spread, many countries affected soon acquired their own cadres of engineers. British engineers and contractors designed and built a vast number of railway lines, port installations and other works around the globe. Their French and American counterparts were also making their mark. And it was the Frenchman de Lesseps who constructed the Suez Canal and began the Panama Canal. And French engineers produced two of the most enduring icons of the 19th century, the Eiffel Tower and the Statue of Liberty. Foreign firms were beginning to challenge British engineering supremacy. So although the 1851 exhibition displayed Britain as the workshop of the world, it also acted as a showcase for leading firms from elsewhere. The star exhibits included the American McCormick Reaper and the huge steel ingot cast at the Krupp Works in Essen. Subsequent exhibitions at New York, London and Paris and Philadelphia made it clear that many countries now possessed ingenuity and skills to rival and frequently surpass British producers. Here's some amazing photos of the Forth Bridge, built to carry a railway across the Firth of Forth estuary in Scotland. This cantilever bridge was the biggest steel structure in the world. When completed in 1890, it took nearly 8 years to build, required 54,000 tons of steel. A demonstration of the cantilever principle at the top with upper lattice girders in tension and lower tubular members in compression. The massive cantilevers here are under construction. Of course, the Brooklyn Bridge, another major landmark in bridge construction, completed in 1883 with a span of 490 metres. It was half as long again as any bridge built at that time. This most radical feature was the choice of crucible steel rather than iron for the huge suspension cables, proving the superior tensile strength of steel. And the Suez Canal became a major vital waterway not only for trade between Europe and Asia, but for British imperial interests. This is the British steamer SS Malabar passing through. These are great exhibitions. So we have the Great Exhibition of 1851 held in the Crystal Palace in Hyde Park. On the continent, national exhibitions have been held for many decades, but on the insistence of Prince Albert, the event was transformed into the exhibition of works of industry of all nations, and over 100,000 objects were shown by 14,000 exhibitors, of whom nearly half of them aboard. One of the greatest attractions was the display of 23 machine tools by Joseph Whitworth & Co., one of the world's leading engineering firms. Other exhibits included carpets, tapestries, furniture, household ornaments and even false teeth, and the space allocated for American exhibitors in 18 system was being studied by a committee of which Sir Joseph Whitworth was a member. The 1862 exhibition was held in London on the site of what is now the Natural History Museum, the Science Museum and Imperial College. The buildings were later moved to North London, where they formed the first Alexandra Palace. Ali Pali, as it's known here. So the photograph here of the iron and general hardware section shows prize-winning plumbing artefacts in the foreground, together with zinc roof coverings. And behind is a still by Henry Pontifex and Sons, coppersmiths and engineers, manufacturers of apparatus and machinery for brewers and distillers, and also for the East and West India markets. The most notable industrial exhibit was the collection of textile machinery shown by the Platt brothers. At the 1876 Centennial Exhibition in Philadelphia, the first major US exposition, all the machinery show was powered by the huge 1500 HP Corliss steam engine. The exhibition was also the setting for the first public demonstration of Alexander Graham Bell's telephone. A very famous structure, of course, the Eiffel Tower, built to accompany the 1889 Paris Universal Exhibition. Gustave Eiffel's 307-metre tower quickly became one of the most enduring icons of the 19th century, despite being scoffed at by all the cognoscenti and opinion makers beforehand. Both the design and the material used, wrought iron lattice girders, reflected Eiffel's considerable experience as a bridge builder. Eiffel is in a top hat on the steps of the tower here. Celebrating man the maker. So the works of engineers were celebrated in permanent as well as temporary exhibitions, and the tradition began in Paris during the French Revolution, when an ancient monastery was taken over as an educational centre for displaying the wonders of engineering. In Britain, the South Kensington Museum was established on the back of the Great Exhibition, and the Patent Office Museum was formed to show aspiring inventors the best of what had been done. The science collections of the two museums were amalgamated in 1884 and renamed the Science Museum a year later. There, Stephenson's rocket, Arkwright's spinning frame, and other icons of the Industrial Revolution were saved for posterity. And after the Centennial Exhibition of 1876, the U.S. Smithsonian Institution displayed American technology in the National Museum building in the middle of Washington. So elevated with the standing of the engineer that man came to be defined as such. Discussions of evolution, precipitated by the publication of Charles Darwin's Origin of Species, seemed to throw into doubt traditional images of mankind as set apart from all other beings. If man was the result of past selective pressures, the direction of his future evolution was unclear. To some it appeared that the use of machines would be a determining feature of human evolution. In creative evolution, the extremely popular work by the philosopher Henry Bergson, published in 1907, Homo sapiens, rational man, became Homo faber, man the maker. Here is some wonderful entrance doors to the original South Kensington Museum. The panels portray British luminaries of science and technology. The Deutsches Museum in Munich. Here's the Kaiser at the opening of the original exhibitions in 1906, and despite the pomp and circumstance, the museum set new standards.